Hi there, in this lesson we're going to look at something called probability. So as you can see in the screen, we've got probability as a measure of how likely something is to happen. And I've got a wee diagram down here of what's called a probability line. It tries to help us sort out the ideas behind this. So if you imagine this probability line, it's important to understand what's at either side of that firstly. So you've got things down this side which are impossible. I've got a wee picture of a dinosaur there. Obviously, somebody could argue about Jurassic Park things or not, but they are impossible at the moment. You can't have a dinosaur kicking about and running about your house or whatever else. And on the other side of the probability line, you've got things that are certain. Things that are certain are like tonight it's going to get dark. Well, at some point, if you put paper in a fire, it's going to burn unless you start saying it's special paper or whatever. Basic stuff like that. Or that tomorrow is going to be the day after today and so on. So they're your kind of main bits at the end of the line. Now it's important to understand that we can associate numbers with these. So impossible we usually give the number 0. That makes sense, 0 impossible. Now the other side certain, I've heard certain people thinking that it's 100 or so, which is a valid idea, but we usually use 1 for that. So certainty is 1 and impossible is 0. Now you've got these things kind of in the middle, right? Bang in the middle is like a 50-50 chance. That's like an even chance, 50-50. Now what I've got here is a picture of flipping a coin. You've got an even chance of getting a head or a tail because there's two sides on it. And then between an even chance and certainties, you get things that are quite likely to happen. And then between even chance and impossible, you get unlikely things to happen. Basically, everything in between 0 and 1, though, can be written as a number. I know I've got words here, but you can write things between 0 and 1, and they're usually written as fractions, decimals, or percentages. Usually fractions at this case. But we can go into decimals and percentages absolutely fine. For example, 50-50 is right in the middle of 0 and 1, so that would be like 50% or 0.5 or 1 over 2. That's what that would be denoted as. Okay, a wee couple of things here then. What's the probability that if today is Tuesday then tomorrow's Friday? Well, that's impossible, isn't it? That's not going to happen. It will be dry every day in January. Well, it's kind of unlikely, isn't it, to be dry every day in January? January's a winter month. If I toss a coin, it will land on heads. Well, that's 50-50, isn't it? I'm not going into this one, but if I put my hand in the fire, I'll get burnt. That's a certainty, all right? Right, let's look at more at writing it as a number or a fraction or so on. So, the probability of an event happening means what fraction of the time it will happen. Now, to understand that, I've got a wee example down here. I've got this person here. There's 10 spheres in the jar. And if you're blindfolded, what's the probability of picking a blue, firstly, and the probability of picking a red? Now, notice the notation here. I don't write what probability of blue equals. It's P for probability, and then bracket, and whatever you're trying to find goes in the bracket. There's a blue there, and P of red. Now, to get the probability of picking a blue ball, then what you do is you look at all the blue balls, and you get 1, 2, 3, 4, 5, 6 blue balls. So you write 6 in the fraction. And the bottom number is what you've got in total, everything in the jar in total. So 6 out of how many in total? And in total, if you count all these up, you'll get 10. Now, once you've got that fraction, it's quite handy to simplify it if you can. So 6 out of 10, you could simplify that by dividing top and bottom by 2, and that would be 3 out of 5. Now, the probability of getting a red ball in this case, if you look at them all, if you're blindfolded and you're trying to pick a random ball out, well, there's 4 red balls, and again, out a total of 10 altogether. So your chances are 4 out of 10. And again, you can half the top and the bottom and simplify that fraction to 2 over 5. So there's a formula to work out probability. And basically what you want in the top is the things you're looking for. They're called favourable outcomes. So what I'm looking for the blue balls here, and out of how many in total, the number of possible things in total there, which is 10. Okay, let's do a few more cases here. So let's look at this idea here. Given the 10 cards, what's the probability of picking a prime number? Right, well, we have to firstly identify what the prime numbers are. So a prime number is a number that divides by itself and 1 only. It doesn't divide by anything else. So I've written probability of prime, and I've given the prime numbers here, which are 2, 3, 5, and 7. Those are the prime numbers in this list. 1 is not a prime number because the factors are the same. So how many prime numbers are there? There's 4. out a total of 10. And again, we would try and simplify that down if we could to 2 over 5. Right, second question, what's the probability of picking a card less than, that's a less than 6 symbol. So what's the probability of picking a card less than 6? We have to think how many cards are less than 6. 1, 2, 3, 4, 5. There's 5 out of the 10. And again, you can simplify that down. You can divide the top by 5 and the bottom by 5, and you're going to get half. It's up to 50-50, or even chance, wouldn't it? And the last question here, what's the probability of picking a 7 of clubs? Well, you can see there's no black cards up here. So the probability is 0 out of 10. Now, if you divide 0 by 10, you just get 0. So that's impossible, isn't it? You can't pick a 7 of clubs out of that lot there. Okay, I've got one more example to show you. This is a kind of slightly different idea. So we've got 3 strikers who have scored the following goals. We've got Messi, we've got Ronaldo, and we've got Suarez. Messi scored 8 goals in 11 matches. Ronaldo 10 in 13 matches, and Suarez 6 in 8 matches. Who's the best chance of scoring a goal in the next match? So basically what you want to do is find out who's got the best probability here. So again, we can write it as a fraction. Messi scored 8 out of 11. Okay. Ronaldo scored 10 out of 13, and Suarez scored 6 out of 8. Now, to compare these as fractions is quite difficult. You think, well, which one's the best? I'm not so sure. So what we tend to do is turn it either into a decimal or a percentage. That's the easiest thing to do because they're easier to compare. Who's got the highest value? It's easier to compare decimals and percentages. So in order to turn it into a decimal, just do 8 divided by 11. That's a divide sign in maths. And you'll get this 0.727272. And to times it, if you times it by 100, it turns it into a percentage. So that would be 72.7, just round it to 73%. Okay, so we've got Messi getting 73% of his goals in the last 11 matches. So, Ronaldo, he's 10 out of 13, so just do 10 divided by 13, and that's what his decimal is, 0.769. Again, if you times that by 100, you get 76.9, and that would be 77% to the nearest percent. And lastly, Suarez, 6 divided by 8, that's 0.75, times it by 100, 75%. So you can clearly see who's got the best percentage record. It's Ronaldo. So Ronaldo has the best percentage, therefore is the best chance of scoring in the next match. So harder to compare fractions, easier to compare decimals or percentages.